Assalamualaikum warahmatullahi wabarakatuh. We are Group 4. Straightforward to our discussions, we'll disclose our understanding in studies of stochastic differential equations, STE applications in medic field, from a journal titled The Stochastic Differential Equations Model for the Spread of HIV Amongst People Who Inject Drugs.
Studying the HIV transmission had the deterministic Kaplan model in 1989 constructed. Then, in the same decade, Cranhart and Hay in 1997 introduced STE model to study the spread of HIV among people who inject drugs. Kaplan model analyzed the behavior of HIV among a population of PWID. Cranhart and Hay derived a stochastic differential equation using the well-known standard technique of parameter perturbation for fraction of PWID who are infected with HIV at time. These are the parameter representation in the studies, and this research has necessarily focused on probability P1 plus P3 of HIV transmission to a susceptible PWID. These are the two variables of the research. From the deterministic model by Kaplan 1989, Cranhart and Hay defined the basic reproduction number for the modified model to be, where D stands for the deterministic. This is correlated to infected PWID who get the HIV after taking a shot of a needle from original infected PWID.
As the environmental stochasticity has been introduced to the studies, there is the Brownian motion. The researchers substitute the parameter epsilon with the intensity of the noise, which is related to potential rate of infections. The total number of new people who inject drugs is denoted in a small time interval. Tt plus Dt is normally distributed with mean and variance. Tt plus T0 is separated by N0 into subinterval, where we say there is the partitions of increment happen, which N0 is a very large number and it led to continuity of path. From the illustrations of the time interval above, we say that when P0 is equal to Tt plus T0, the Brownian motion started at Tt plus T0. As a result, the STE HIV model as follows. The reason why epsilon was chosen is corresponding to the total rate at which people who inject drugs visit strangers and potentially become infected, where there is the key parameter in the transmissions of HIV amongst people who inject drugs.
The researcher first show if the STE model has a unique global non-negative solution where satisfy the linear growth condition and the local Lipschitz condition. Gradually, from the deterministic basic reproduction number, the research then formed the SDE basic reproduction number as stated equation. After all, the result of disease existence came out with two states of which are extinct and persistence. In the study of dynamic behavior of the population, they consider the conditions of HIV in between the circle of PWID to die out or extinct. Therefore, the disease is said to be extinct when R0S is less than 1. Not to exclude, the study also take the random variable X to integrable by Ito formula. Then, the disease is considered persistence when R0S is greater than 1. Say that there will be two possible events, no disease present and disease present.
The researcher then simulate the analytical finding of extinction and persistence state through numerical simulation produced in our software. The simulation were constructed for multiples of times with differences of parameters and intensity of noise to study the behavioral pattern in the study. These are the figures that show simulations on extinction followed by the simulation on noise intensity epsilon. In the conclusion, Cranhart and Hay has successfully introduced environmental stochasticity into the studies.